Today we will continue to study hydrocarbons. We have seen that element carbon, has 4 valence electrons, and it therefore can form 4 bonds. Yes? It can form 4 bonds to hydrogen, forming methane. So now we're beginning to name these compounds. Also, carbon bonds to other carbons and forms hydrocarbon chains. If these hydrocarbon chains have nothing but single bonds, what is this series called? Alkanes. So we're going to be talking about methane. How many carbons in methane? 1, ethane, 2, propane, 3, butane, 4, pentane, 5, and nothing but single bonds, hexane, 6, heptane, 7, octane, 8, nonane, 9, decane, 10. If we sprinkle double bonds in there, then we're no longer dealing with alkanes. Now it's alkenes, so it's going to be ethene and propene and butene and pentene. So the ending ene means you have a double bond in there. Okay? But the stem, but still means 4 carbons. Pent still means 5 carbons. Okay, so 4 carbons and nothing but single bonds is butane. 5 carbons and nothing but single bonds, pentane. And that was homework a while back. If we have triple bonds, not single or doubles, what do we have? Alkynes, and now it's going to be ethyne and butane. What does pentyne mean? How many carbons? And what do I have in there? A triple bond. And hexyne, how many carbons? 6, and I have in there a triple bond. So today we'll talk a little bit more about those guys. We also have seen, so I am referring to this list, the alkane series. This is step 1. Okay, so we change those names, same stem, and instead of having ANE, meaning alkanes, we have ENE. It's double bonded, people. Okay, so you're going to make another series, and you're going to call them the alkenes. Then you're going to do another series, and you're going to call them the alkynes, and those are going to be triple bonded. And we also did the alkyl groups series, and those were branches. So if we have a parent chain, a longest continuous chain of 5 carbons, and then you put a methyl in there in position 2, then from methane you go to methyl. So these guys are all now going to end in YL. Those are going to be alkyls. But if your branch only has 1 carbon, it's methyl. If your branch has 2 carbons, it's going to be ethyl. If your branch has 3 carbons, it's going to be propyl. Okay, so this first 10 alkanes will take us places. This is step 1. There is no way out. So don't have dinner until these are in your head, because everything else will follow based on you knowing these. Okay? To name alkanes, we said we find the longest continuous chain. You call that parent chain. The PC meant parent chain. That's the longest continuous chain, and it does not look straight. We may want it to look straight and draw straight line of carbons, but that's not what their 3-dimensional structure does, because every angle is 109.5 degrees. And after you find the longest continuous chain, then you number it. So it's finding it and numbering it. That's all we're doing. And then there's a rule 3, which we'll review in a minute. Let's just review this first 2. Methyls and ethyls. When we talked about isomers, what was isomers? Isomers had same number of carbons, same number of hydrogens, meaning same molecular formula, but different what? Structures, meaning they're different compounds. So for a continuous chain of 5, continuous, notice that we drew zigzag. Each one of these carbons is 109 degrees from each other one. Or you can write 5, 1, 2, 3, 4, 5, like a U, facing up or facing down. That's still pentane. Okay, and then if you chop one carbon, and your continuous chain, the longest continuous chain, is now 4 carbons, what's that? What's that parent chain with 4 carbons? Butane. And now you have a branch, and that's a branch of 1 carbon, so that's a what? A methyl. You give it a number, you give it a position. If methyl is in position 2, that's a 2-methyl, and the whole name is 2-methylbutane. Yes, we remember this good stuff? And we did it for isomers of C5H12, and then we did it for C6, and we made relations. So if I am going to make a connection between a continuous chain of 5, 1, 2, 3, 4, 5, and a branch of 1, 1, 2, 3, 4, 5, on a branch in 1, does it matter if I put the carbon up or down? Is that different? Or if I start from the right, or if I start from the left, does it matter? No. So what's this guy's name? That guy looks very much like that, but these two guys are identical. Okay, so what's my parent chain? My parent chain, my PC is what? Find it, and it's 5 carbon, so it's pentane. And then I have a branch of only 1 carbon, so that's a methyl, and it needs an address. So I go 1, 2, 3, 4, 5 from right to left, because the criteria was get that branch the lowest possible number. Okay, so this chain and this chain are identical. So is that and that. If I have it there, then I go 1, 2, 3, 4, 5. And that's still 2-methyl pentane. Yes? Questions up to there? Okay. What about that? Hexane and 2-methyl pentane are isomers, because hexane is containing 6 carbons and double plus 2, CnH2n plus 2. Double the 6 is 12 plus 2 is 14. This guy is hexane. 1, 2, 3, 4, 5, 6. 3 H's and 2 and 2 and 2 and 2 and 3. That's hexane. That's C6H14. And then if you put a parent chain of 5, so your parent chain is no longer 6 but 5, and now you have a methyl in carbon 2. That's a branch. So that's 2-methylpentane. That's also C6H14. So they're isomers. Have the same molecular formula. And I said if you don't change the skeleton, if you have nothing but single bonds, they'll all be isomers, as long as you don't change the number of carbons. You can't change the number of links in there, or the number of carbons, really. What if I put that carbon in position 3? Is that the same as this one? 1, 2, 3. I can go down, and then I go the carbon here. Who's this guy? He's none of these guys. He's none of those guys. It's none of those. What's my parent chain? My longest continuous chain. The word straight is not in my definition. And then this fellow is a branch. Okay, so we strip them all from the H's, no hydrogens, because we know how to fill them up. 3, 2, 1, 2. All we need to do is put 4 bonds to every carbon. That was our first statement. So what's this guy's name? 3-methylpentane. So instead of having the methyl in position 2, now I have it 3-methylpentane. And I don't have a picture of a chain like that. What about that guy? I have a continuous chain of 1, 2, 3, 4. And then I have something here. What's my parent chain? Butane. Now you could call that parent chain. Okay, so we did the links using the chains, the carabiners, to make a simple connection of you linking a new chain. So what's this fellow's name? My parent chain is, first you find it, butane, and then this guy is not my parent chain, therefore it's a methyl. It needs an address. So is this guy. So you need to then find it and then number it. Who's carbon 1? 1, 2, 3, 4. So this methyl gets position 2. This methyl gets position 2. You find your parent chain, your longest continuous chain. You number the parent chain so that your branches get the lowest number. What if we don't have methyls, but we have chloro? I just changed it. What would this guy's name be? 2-chloro, 2-methyl butane. Okay, so the chain examples are good for you to find the longest continuous chain. Okay, so you can think of this chain of carabiners, or you can look at a train that's going from west to east, down south, but it's one body. And if it has 4 carbons, it's butane. Yes.
Does it matter where you start numbering?
Yes, it matters. Okay, let's go back to what we had before. Let's go back to our first. I had a methyl up there and a methyl here. Yeah? 2 minutes ago, this is what this looked like before I changed the example. What would have happened if I would have called, let me change colors, if I would have called him carbon 1 and him carbon 2 and him carbon 3 and him carbon 4? Are my methyls in position 2?
No.
My methyls are now in position 3. Is that the lowest number that I can give my methyls? So where do I number them? So that my methyls get what? The lowest number. So that's all I've thrown at you. You find the longest continuous chain, you find your PC, and then you number this parent chain. And I didn't say start from the left and go to the right, or start from the top and go to the bottom, or start from the right and go to the left. No, you start from wherever you may start, because, and this was the example, whether you start from the right and go to the left, and your chain branch is in position 2, or you start from the left and you go to the right, guess what? That chain and that chain is not different. Okay, so if they're chains and they're not different, this is not any different. Whether I put my carbon there, my methyl there, or my methyl there. Okay, it's like you're flipping it like a pancake. And you're not a different person just because you turned around and gave your back at me instead of facing me. Okay, neither is this thing. Okay, so the minute you begin to relate to these simple examples, then organic chemistry is not such a crazy deal. Yes, sir.
Is the whole the chloro always first in the naming of it?
Halogens is what you, not the chloro, because you could have FClBrI. Remember group 7 halogens? They get priority over methyls and ethyls, over the alkyl groups. Okay, so you need to know the names. Alkanes mean something. Alkenes mean something. Alkynes should begin to mean something to you. Alkyl groups, those are branches. Methyls, ethyls, okay? Like in here. My parent chain, remember these guys? These were cycloalkanes. I want to talk a little bit more about cycloalkanes. You had a question? Yeah, before I move on to cycloalkanes. You have to do it. You have to sweat it out. There is no formula for me to tell you there are 4 isomers here and 9. The homework that I gave you, the isomers for C7H14, I helped you out and I said there's a total of 9. And if you found 20, it's because you're repeating the same thing. You're flipping it like a pancake and you're calling it a different name and it's wrong. So all I'm asking you to do is find the longest continuous chain, number it so that the branches get the lowest number every single time until it gets ingrained in your head. And that's a tough one. So that homework is wonderful. How many people did that homework? Not very many. So I'm not even going to discuss the homework, so you'll catch up with me. Okay, we did a little bit about cycloalkanes. So that whole list of butane and pentane, this whole list. Okay, so these 2 rules is all we have seen. And then yes, you name it alphabetically. Okay, so we'll review that. And we'll review this whole list Now, first you learn it with alkanes, with alkyls, with alkenes, with alkynes, and then you go to cycloalkanes. And then you go to cycloalkenes. And it's the same, okay? So I'm going to do a cycloalkane, but I'll bring you back the alkane first, okay? So I'm assuming we know alkanes, and you're going to do many of these. Many of these. One for alkanes, one for alkenes, one for alkyl groups. Okay, so if I have a parent chain of 3, and I'm stripping it from the H's, is that a problem? How many H's is the first carbon going to have? And the second? And the third? And who's this fellow? Who's CH3, CH2, CH3? Who's that? That's propane. Okay, so that's step 1. If we don't know that, we're not going to be able to move from there. But if you're thinking that this is propane and you have no problem, and then you flip him up, just bring him up like this, is that any different, guy?
No.
That's still the same. Okay, I just moved him around. But if I connect this too, if I bond those two guys at the end, how many H's is this guy going to have? 2. And this guy, 2. And this guy, 2. Because carbon has a valence of 4. Carbon has a valence of 4. Have I said that enough? You cannot have 5 bonds to carbon. Okay, just like you have 2 arms, you don't have 3. Or 4 arms, or 2 heads. You know, you have whatever you've got. Well, carbon has 4 bonds, period. So this guy is no longer propane. This guy is what? Cyclopropane. Is cyclopropane an isomer of propane? Are they isomers? No, why not? This guy is C3 double plus 2. That's C3H8, right? That's an alkane. CnH2n plus 2. And cyclopropane is C3H6. So if this guy has 2 H's, and this guy has 2 H's, and this guy has 2 H's, I only have 6 H's. So these two guys are not isomers, because I no longer have the same molecular formula, and they're totally different. That's cyclopropane. And I draw them like this. I clean them out like that. A little triangle, meaning every vertex is a carbon, and every carbon has a valence of 4. Every carbon is bonded to 2 carbons and to 2 H's. And you can turn it around all you want, and there is no top or bottom or left or right. Flip it around like a pancake and it's still the same. Let's do it for... Okay, let's just review this guy's name.
Can you go over one more time why you can only put 2 hydrogens?
Okay, count to 4 with me. This carbon right here, I'm looking at this carbon and the tipping up.
Oh, 1, 2, 3, okay.
Has 1 bond, 2 bonds, 3 bonds, and 4 bonds. This carbon right here has 1 bond, 2 bonds, 3 bonds, 4 bonds. Let's pretend they stay. Let's pretend all the bonds stay. This carbon right here has what? 1 bond to this carbon, 1 bond to that carbon. 1 bond and 1 bond. So how many bonds does carbon have, guys? 4. Okay, so every one of these is a carbon, and every one of them has 2 H's. And I don't draw the carbons, I don't show anything. Okay, let me make one more. Let's go butane. What's butane? How many carbons? 1, 2, 3, 4. Do we go butane or do we go pentane? Skip to pentane? Yeah? Okay, pentane. 1 more carbon. How many H's is the first one going to have? And the second one? And the next one? 2 and 2 and 3. So it's CH3. How many CH2s? 1, 2, and 3. So I can group them like this and CH3. That guy is pentane. Now, what about if I do this? 1, 2, 3, 4, 5, and 6. And they're all connected. Are the carbons at the end going to have 3 H's? No. There is no carbon at the end. This is like a Ferris wheel. And whoever's on the top is going to be on the right and on the bottom in no time. You can turn them around. Every carbon has what? 2 H's. So for alkanes, it's CnH2n plus 2. For cycloalkanes, it's CnH2n without the plus 2. Because you're bonding the two N carbons. You took hydrogen out of there, and you connected these two guys. Okay? And how do we clean them out? So this guy has two carbons, two hydrogens, sorry. Two hydrogens, two hydrogens, two hydrogens. And what do I draw? A little pentagon. This is where you need to go. This is how it's going to come your way. And if this is your first cycloalkane experience, then translate into here and go into your alkanes. Go to where your comfort zone takes you. Okay, so we remember that. And we were going to name this little guy. So we had a cyclopentane, yes? And that's our parent chain. So finding the PC, finding the parent chain is no big deal. Finding the parent chain is the easiest because it's a cyclic structure. Okay, so if you have a cyclic structure, I'll show you a model of a cyclic structure. That's a cyclic structure. Okay, that's cyclopentane. Doesn't matter if that guy's in the top or that or that. It has an iodo and it has a, what is that? A branch of 2. Methane, ethane, propane. That needs to be clear. What's a branch of 2? Ethyl. Ethane is an alkane. This is a branch, so it's not an ethane, it's an ethyl. All you do is remove an H from ethane. And now you bond it to a parent chain. And your parent chain now is cyclopentane. Yes? Are we okay? I'm reviewing this example. And then this carbon has an iodo, and this carbon has an ethyl. Why did I give the iodo? Halogens have priorities, very good, over alkyl groups. So the carbon that's bringing the bromo, the carbon that's bringing the fluoro, the carbon that's bringing the iodo, that gets a lower number than the carbon that's bringing a methyl or an ethyl or a propyl or any other alkyl group. So this carbon right here gets position 1. This is carbon 1 because it has an iodo. And once I decide that that carbon is 1, and again, what's at the bottom could be on the top. There is no top or bottom. Then I go 2, 3 to get the ethyl. And then when I say it, once I know that my ethyl is in position 3, that's an ethyl in position 3, and my iodo is in position 1, I don't go 1, 2, 3, 4, 5. I go alphabetically E before I. So I say 3-ethyl, and I call this fellow first. And that has a CH2 and a CH3. That's my ethyl. 1 iodo, and that's calling this fellow right here. And then my parent chain, and this is my PC, my parent chain. Cyclopentane.
So the halogens only have priority in the numbering, not in the name. They still fall under alphabetical.
Exactly. You first, the last thing you do is the alphabetical. Okay, so it's 1, 2, 3. Number 1, find the PC. The cyclic structure. Number 2, number the parent chain so that the halogens get priority and the alkyl groups get, everybody wants to get the lowest possible number. Halogens getting priority. They get the spotlight. They're the head honchos in this little story. And then after everybody has a number and everybody has been assigned, and then you put it all alphabetically.
So when you name it, it's by alphabetical.
Yes, that's rule 3. Okay, so those were the 3 steps. Name the alkane. Okay, so this little thing, make an index card, and the very first thing you're going to do is find the longest continuous chain, the PC. And the second thing you're going to do is what? Number the PC. You number it. So that the whatever substitutes, and we put a blank. Because sometimes we only have alkyl groups, methyls and ethyls. Sometimes we're going to have halogens. Today we're going to have double bonds and triple bonds, and they need to get priority. And number 3, after everything's done, then what do? You go alphabetically. A, B, C, D, E, F, G. Yes? Let's do...
Numbering your alkane chain.
Mm-hmm.
Do you worry about the alphabetical and the numbering or not at all?
When you're what?
You don't. You number.
Yes,
first.
you always you number first, and then you, when you're about to baptize the guy and gave him a name, you go alphabetically.
Then you alphabetical. Okay.
That's the 3rd step, after you've numbered.
Okay.
Number first, then alphabetize.
Okay. Can there be a halogen in your plain alkane? train, one,
Can there be a halogen on the
yeah,
on the what?
on the, what we were doing before.
On an alkane? Sure.
Okay.
Why
And
do
then
you
would
do
you
this?
consider that in the numbering?
Yeah.
Yes, okay.
Okay, so if you have this 1, 2, 3, 4, 5, 6, 7, and I have a bromo here,
You want that
and I
first.
have, well, I want you to name this tune for me. And what do you do first? What's rule 1? Find the parent chain. So go find it. And this is an auction, and I'm going to give it to the highest bidder. And I hear 7. What else do I hear? I hear 8. What else do I hear? Do I see 6? Is there anybody thinking 6? I'm sure there's people out there that think it's 6. Do I see, I don't know, 10? E? None of these. None of the above. And that we're only in rule 1. We first find it, then we number it, then we alphabetize. In that order. What's my parent chain, guys? Go. Okay, so where do I start? Where do I start highlighting? Let's highlight with yellow. Bottom, this guy? You want me to go here? And then, I don't want to go right because that would only be a parent chain of 4. I didn't even have that. So I go left. Maybe. Maybe. Come on. And then, do I go all the way to the end because it's nice and straight and my kindergarten teacher told me to go straight? No, I don't. I want the longest continuous chain. The word straight is nowhere in the definition. So anybody that I didn't highlight is a what? That's what? That's a methyl. That's a branch. So he needs an address. He needs a number. I didn't highlight him, so what's that? That's another methyl. And I didn't highlight him. So what's that? That's a bromo. So they all need addresses. So after I have found my parent chain and identify everything in here, then I go to rule 2. Now I'm in rule 2 and I'm ready to number. So I have 2 ends. Either this fellow on the top is carbon 1 or this fellow on the bottom is carbon 1. And if I flip it like a pancake, whatever's on the top is going to be on the bottom. So there is no top, there is no bottom. Who is carbon 1? If I go 1, 2, 3, 4, 5, 6, 7, 8, my bromo has position 7. If I go 1, 2, 3, 4, 5, 6, 7, 8, my bromo has position 2. So my halogens get priority over everybody else. How does the halogen get the lowest number? Starting from the bottom. So these red ones are out of my life. Except I'm going to leave them there because everything is erased. So that bromo gets position 2. It's a 2 bromo. And once I decide that that's a 2 bromo, that methyl gets position 3. And that other methyl gets position 6. So I'm done with rule 2. I have numbered my parent chain so that my everybody gets the lowest number, starting with my halogens. Now I go to rule 3. And B or M, what's first? B. So it's going to be what? 2 bromo dash between the bromo and the next number. Dashes between numbers and letters. 3, 6, and if you don't put a comma, it says 36. And that's not what we want. And it's 2 methyl, so I call a dimethyl. And it's a what? Octane. That's all. Not so bad. So that's what you wanted, a halogen on a open chain. These are called open chain as opposed to rings, as opposed to cyclic chain. Okay? What about if I have this guy? See who's red and who hasn't really read. I had a bromo a minute ago. Name this. Find the parent chain. What's the parent chain? And force yourself to go 1. What's my parent chain? What is it? 6. My parent chain is called 6. That's a nice name. It's not hexane, it's cyclohexane. And it's not called 6. It's called cyclohexane. I found my parent chain. Rule 2, I need to number this parent chain. The one, what I'm numbering is the carbons. The chloro doesn't get a number. The carbon that carries the chloro gets the 1. Okay, so I suggest strongly for you to draw your chloros because they're hiding, and this is your first lecture in cycloalkanes. And it'll take a minute for you to see that every vertex means a carbon. Every vertex, like I'm showing you with my hands, is a carbon. I just don't draw them. Okay? So who's carbon 1? And let's do it. The carbon was the chloro. And then do I go clockwise just because that's the way my clock goes? And I like that. I love clockwise. So is he going to be 1, 2, 3, 4 like that? If I do that, that's 2, that's 3, this little fellow is going to get position 4. And I think I can do better than that if I go counterclockwise. So if I go 2, 3, 4, 5, 6, this little fellow gets position 3. So that's the way I'm going to go. I'm going to go this way. So you go clockwise or counterclockwise so that my substituents get the lowest number. And I'm done with rule 2. Now I need to baptize this guy, number 1, and I need to go alphabetically. What is this fellow called? Who's red? Let's see who's really paying attention. Yay! Who said that? Awesome. Isopropyl. What's the difference between an isopropyl and a propyl? Okay, if I wouldn't have done that, okay, I'm going to change it. I'm going to cheat for a minute. That is a propyl. Propane has 3 carbons. Propyl is a branch. Yes, an alkyl group. So if I have a straight, continuous chain of 3, and the carbon at the end is bonded to my parent chain, this is my parent chain, and that's bonding at the end, that's a propyl. But if I don't have the carbon at the end, but the carbon in the middle, he is just as bondable as anybody else. Okay, so that's an isopropyl. And that isopropyl gets position, what? 3. Okay, so I'm going to call it what? 1 chloro, 3 isopropyl. Let's pretend rule 3 goes here alphabetically. Rule 2 was to number the parent chain and then name it alphabetically. And then my parent chain is what? Cyclohexane. In the lab, you don't have multiple choice and you have no idea how many people mean to write cyclohexane and they write hexane. They write stuff that you don't mean to write. So don't do little homeworks. Do lots of homeworks. Get lots of practice, because he'll kill you when you do silly things like that. Okay. So any other questions in there? No? We're good? Move on? Let's do it the other way around. Let's go to page, exercise number 2. Page 154. Pick one from there. Like how about D? 1 ethyl, 4 isopropyl cyclohexane. Page 154. Problem 2D. And they want me to write 1 ethyl. Okay, this weekend you want to sweep all of module 4. All of it. Sorry, module 9. Sorry. 4 isopropyl cyclohexane. Okay. If you open your medicine cabinet, all the names are like that. You take a whole line maybe 2 lines and 3 lines. And now you're going to be able to say, oh, look, I know that. You can show off. Okay, so you always start with the parent chain. What's a cyclohexane? A cyclic chain of 6. And then you're numbering it. So I like to put number 1 on the top and go clockwise because I want to. Okay, so if you're drawing it, you call your shots, whatever you like. And then you trim it. Position 1 gets an ethyl. What's an ethyl? How many carbons in an ethyl? 2 carbons. So it's a CH2, CH3. And position 4 gets an isopropyl. How do I do it with isopropyl? Carbon and carbon and carbon. It's like a little Y. And the carbons at the end has how many H's? 3, and the guy in the middle has 1 H. So if you know how to count all the way to 4, you drew it. Not so bad? Okay. The next section in there is reactions. I am not going to go to reactions because I see some of you smiling and you see some of you frowning. So I am going to move on to alkanes, from alkanes to alkenes, and to alkynes, and then we'll move back to reactions. And maybe we'll even do alcohols before we get to reactions. What was alkenes again? What did they have? I have a hydrocarbon chain with double bonds, at least 1 double bond. And now I'm thinking not ethane, but what? Ethene. Not propane, but propene. Not butane, but butene. And these, if I only have 1 double bond, that's the general formula. And if I have triple bonds, what do I have? Not ethane or ethene, but what? Ethyne. Not propane or propene, but propyne. So those first 10 alkanes need to be addressed. And the general formula is remove another 2 hydrogens every time you have another bond. The general formula for the cycloalkanes was also CnH2n. Remember that from last time? So if I have this guy and I'm stripping the H's, what's this guy's name? Ethene. Yes, it's like you're learning a new language. You are learning a new language. And you can add your H's anytime. What about if I have a triple bond? What is this guy's name? Ethyne. So you start with ethane, 3 H's and 3 H's. That was ethane. That was last week's news. Pretend this guy has 3 H's. It doesn't want to write. So you start with ethane and then ethene, ethyne. So all you're doing is changing the ending. What would this guy be? How many carbons? If it was an alkane, what would that be called? Okay, so you go from alkanes, which you know, to alkenes to alkynes. That's propane. So that's not propane, it's what? Propene. And what is this guy? Propyne. Are we okay? So you need to do that whole little thing of ethene, propene, butene, pentene. Let's do it with 4. 1, 2, 3, 4. What is this guy called? And again, you're thinking, oh, I know the single bonded one. That was easy. If that's butane and it has H, 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 what's that? Butene. What's this? Butane. And these guys are not isomers because this is C4H10. This guy is C4H8. And this guy is C4H6. They're not isomers. They're just totally different people. They're different series. The alkenes and the alkynes are not alkanes. Okay. But can you tell me an isomer of this guy?
What if you have two double bonds? Is that the same?
No, that will be a diene, and in this course we will not have that. Okay? But what you can have is move that double bond from position 1 and 2 to position 2 and 3.
Does that even matter?
Of course it matters. They're totally different people. Okay? You're totally different than the person sitting next to you, right? And you're probably...
Call that.
So let's baptize them, because you both need different names if you're different people. How do you name these guys? If I tell you that this guy's name is 1-butene, what would this guy's name be? So what do you do to name an alkene? You find the longest continuous chain containing the double bond. Now it's not a chloro that I'm looking at, it's the double bonds. They get the spotlight. And I want to number it so that the double bond gets the lowest number. Or the triple bond if I have an alkyne. And then I have a double bond, it's got to have 2 carbons. I'm only going to call the smallest of the 2 numbers. So if the double bond is between carbons 1 and 2, I call it a 1-butene. If the double bond is between carbons 2 and 3, I call it a 2-butene. So tell me, what is this guy's name right here? This guy, the butine. 1-butine. Is there going to be a 4-butine ever? No. A 4-butine means you didn't come to class and you started numbering backwards. Okay? If I put the triple bond not there, but there, that's not a 4-butine. That's still a 1-butine. I just go left to right. Same deal. So that the triple bond gets the lowest number. Okay, so you do it with methyls, you do it with bromos, you do it with double bonds, you do it, period. So once you learn it, we're using UPAC, International Union of Pure and Applied Chemistry System of Nomenclature. And it is the same thing. It's one big rule again and again and again and again, just sprinkling alkyls or bromos or double bonds or triple bonds or whatever. But it's very consistent, very powerful. Okay, so there is no 3-butene or 4-butine or crazy stuff like that. Yes? Are we okay so far? Yes? Okay. Now, let me tell you something about this people. I'm zeroing on alkenes. Okay, so you know that alkenes have a double bond. I'm going to show the H's in my first alkene. How many H's does this guy have? An H up there and a second H. What about the guy in the middle? He has? No. This carbon has 1, 2, and 3 bonds taken. So you only have 1 left. 4 minus 3 is 1. What about this guy? Has 2 H's. So and this guy has 3 H's. Okay, so you have your 8 hydrogens. That's 1-butene. Carbon number 1 in the double bond has 2 hydrogens. Carbon number 2 has 1 hydrogen. What about this guy right here? This carbon has how many hydrogens? How many hydrogens does this guy have? 1. And this carbon has 1. And this guy has 3. And this guy has 3. Yes? So I have 3 and 3 is 6, 7, 8. 8 hydrogens, 4 carbons, no matter how I do it. Okay, so we're good? C4H8. Tell me, if I have this fellow, anafluoro, what would that guy be called? I find my parent chain. Step 1. What is it? Butene. I number my parent chain. Does it matter if I go right to left or left to right? No. So it doesn't matter. I go my normal merry way. I address my goodies, and they happen to be fluoros, and they need an address. And then I put it all together. What's this guy's name? 2,3 difluoro, okay? Difluoro, what butene? 1 butene or 2 butene? 2 butene. So you need to, if you have a butene, you need to tell me where the double bond is. Okay, because if I put the double bond between carbons 1 and 2, that's a different guy. Okay, yes, we're okay with this name? We're doing the same U-Pack system of nomenclature. Find your parent chain, butene. This is my parent chain. It has a double bond in carbon 2. Double bond on carbons 2 and 3. So I call it a 2. And I have a couple of fluoros sprinkled around. Now, if I take this fluoro, these angles are no longer 109.5. This, if I am to show you a better picture, a two-dimensional piece of paper, a two-dimensional screen that you're looking at is perfect. I'm going to make you a better rendition of this guy. This carbon has a fluoro and a fluoro and a, this is like a little triangle, and so is this, like a little triangle, like a little bow tie. These angles are 120, 120, 120. Okay, so this 3 H's over here and this 3 H's over here are these guys. That is the same thing as that. Now if I flip these two, if I put the F down and the CH3 up, I'm going to leave this F on the top, right, left, and now I am going to have a CH3 up here and an F over here. What's my parent chain? Still butene. My parent chain was here. My parent chain is kind of crooked, but that's the way they go. That's what they are. That's my parent chain, yes? This guy is different from that. And I only flip the A, the fluorine, with the methyl. If my F's are in the same side of the plane, this isomer receives a prefix of cis. Okay, so imagine a plane here. And both of the fluorines go in the same side of that. If one fluorine is above and the other fluorine is below the plane, what is that called? They're trans from each other, and they are different isomers. Okay? So if I have a double bond, I have an alkene. Yes? Then I look at each carbon in the double bond. Each carbon in the double bond has two non-identical groups, a fluorine and a methyl, and a fluorine and a methyl. A fluorine and a methyl and a fluorine and a methyl. So I'm just looking at this guy first. Not that that's my parent chain, but I'm just focusing my attention there. And if the two fluoros are on the same side, it's cis. And I don't care if they're both above or if they're both below. This is cis as well. But if one is above and one is below, that's a trans. So that's a new type of isomers, and these are called geometrical isomers. Cis and trans isomerism appear on alkenes, only on alkenes. You do not have it on alkanes, you do not have it on alkynes. You, in this course, you're only going to have it in alkenes, y ya, se acabó. Okay, so you tell me, what is the name for this fellow? And notice what I'm doing, I'm stripping the H's, because I can always put them back in. just to really look at the skeleton and find my parent chain. What's my longest continuous chain? Find the PC. Find the PC. Who's the PC? How many carbons? Good. I have agreement in the room. 6 is it. So we all looked at. We're not thinking straight anymore. Thank you. Congratulations. Welcome to organic chemistry. Cannot think straight anymore. I found my PC. And then I number my PC. And it doesn't really matter whether I go on the top or the other. So I number it and it's okay. I can call him 1 and 2 and 3 and 4 and 5 and 6. But I see that I have a cis-trans fellow. Is this a cis or a trans? They're both on the same side, so it's going to be a cis. So my very first step is identifying it. Now I have to put it all together. So its name is cis what? 3,4 dibromo, really loud, I can't hear you. Dibromo. What's wrong with hexene? It's almost right. I'm missing 3. Thank you. You need to position the double bond. The double bond could be here or anywhere. So you need to tell me where's the double bond at. And it happens to be between carbons 3 and 4. So it's cis 3,4 dibromo 3 hexene. If I ask you to draw the trans, what would you do? I pushed what? I would just move these two around. Put the bromo above and that other chain up down, and that would be the trans. Not so bad? You ready to tackle that module 6 this weekend? Module 9. I need some sleep. Have a great day, guys. See you next time.